Hello and welcome back to our soil mechanics video lecture series. In previous lecture we discussed the origin of soil, weathering, transportation and deposition of soil. In today's lecture we will continue from there and understand the classification of soils according to transporting agency, and we will also try to cover regional soil deposits in India. These concepts are very important for understanding the soil behavior and identification in engineering practice. So let us begin. First, let us understand the classification of soil by transporting agency. The first one in this category are water transported soil. Flowing water is an important transporting agency that carries soil particle either in suspension or by rolling along the bed. The size of particle carried depends upon the velocity of water. At high velocity, it can carry the boulders and gravel. As the velocity of water gets lower, it deposits silt, sand and clay. When water becomes almost still, the delta deposits are formed, and the soil deposited in river water, or we can say by river water, are called alluvial deposits, and similarly the soil deposited in lakes are called as lacustrine deposits, and the type of soil which deposited in sea or ocean are known as marine deposit. This diagram clearly shows how the particles settle in sequence as water velocity reduces. Now let us understand the wind transported soil that are also known as aeolian deposits. In this case, the soil particles are carried by wind, and the particle size transported depends on the velocity of wind. Generally, the finer particles are light in weight, so they can be carried to long distances from their place of origin. The soil deposited by wind are known as aeolian deposits, as I have already told in the heading line. A common example of this type of soil are loess. Such soil also have low bearing capacity and have high vertical permeability. So wind acts as an important transporting agent, especially for fine soil particles, and the deposited soil are known as aeolian deposits. Another important transporting agent is glacier. So let us understand how glaciers transport and deposit the soil particles, forming what we call glacial deposits. Glaciers are large masses of ice that move slowly and carry soil particles of all sizes, ranging from fine particles to boulders. The deposits made by glaciers are generally called as drift. When the soil deposited directly due to the melting of glacier, the deposited soil or specifically called as till. An important engineering property of glacier till is that it is generally well graded and it can be compacted to high dry density, and it has high shear strength. So glacial deposits are important because glaciers can transport a wide range of soil particles and form strong compact deposits after melting. Let us now discuss another transporting agent, which is gravity. Unlike water, wind or glacier, Here, the soil particles move downslope due to the action of gravity itself. This usually happens in hilly or steep slope areas where rock fragments and soil masses move downwards and accumulate at the foot or cliff of, or we can say, steep slope. Such deposits are called as colluvial soil. A common example of these type of soil is talus deposits. These consist of irregular and coarse particles. Talus is formed by accumulation of broken rock fragments at the base of steep slope. So, gravity deposited soils are mainly formed by downward movement of soil and rock fragments under the natural action of gravity. So far, we have studied the soil transportation by individual agents like wind, water, glaciers, or gravity, but in nature, the soil movement does not always occur by a single agent. In nature, sometimes two or more transporting agents act together to move the soil particles from one place to another. For example, a soil particle may first move downward due to gravity, and then it may be further carried by wind, flowing water, or glacier. So, in such cases, the soil transportation does not happen because of single agent, but because of the combined action of multiple agents. So, this concept helps us understand that in natural conditions, soil movement can be more complex with different transporting agents working together in sequence. After understanding the soil deposits based on various transporting agents, let us now look at regional soil deposits in India. In India, soil deposits are broadly classified into 5 major groups based on their origin, composition, and regional occurrence. The first in this category are alluvial deposits, which are mainly found in river plains and are very important for agriculture and construction purposes. The second one in this category is black cotton soil. It is known for their clayey nature and swelling behavior. Third one in this category are lateritic soil, which are commonly found in regions of high rainfall and temperature. The fourth one in this category are desert soil. As the name suggests, these are mainly found in arid and dry regions. And finally, we have marine deposits, which are found in coastal regions and influenced by seawater. Let us now understand the first major soil group in India, which is alluvial deposits. These soils are found, as I have already told, in mainly North India, especially in Indo-Gangetic Brahmaputra plains, mainly plain areas. The thickness of alluvial deposits can vary greatly from a few meters to 100 meters in some regions. An important feature of these soils is that they consist of alternating layers of sand, silt, and clay, deposited over time by flowing river water. From an engineering point of view, alluvial soil generally have low density and in earthquake prone areas they may be vulnerable to liquefaction, where these soils loses its strength due to shaking. So Alluvial deposits are widespread in India and are very important both in agricultural and geotechnical engineering. Next, let us move to another important soil type in India known as black cotton soil, which is very significant from geotechnical engineering point of view. These soils are mainly found in central India and parts of South India. Black cotton soil are residual soil formed by weathering of basalt or trap rocks. These are rich in montmorillonite clay mineral and these have high plasticity. One of the major important characteristics of these soil is that they show high shrinkage and swelling behavior when they expand, or we can say when they acted upon by water, or we can say when they get wet they start swelling, and when they become dry they shrink rapidly. From an engineering point of view, black cotton soils generally have low shear strength, high compressibility and low bearing capacity, which can create problems for foundation design. So black cotton soil is an important expensive soil that requires special attention in engineering constructions. Next, we have another soil, regional soil in India, which is known as lateritic soil. These soils are formed by decomposition of rocks where the silica and bases are removed due to intense weathering. Lateritic soil are rich in iron oxide and aluminum oxide, which gives them their characteristics red or pink color. These are residual soil and are commonly found in central, southern and eastern India, especially in regions with high temperature and rainfall. An interesting property of these soil is that they remain soft when wet, but with time they harden on drying. They also show decreasing plasticity with depth and generally have relatively high specific gravity. So lateritic soil are important residual soil with distinct color and engineering properties. Now let's discuss a soil type that develop under hot and dry climatic condition known as desert soil. These soils are found mainly in Rajasthan and adjoining arid regions where rainfall is very low. Desert soil usually consists of sand dunes which are formed under dry climatic condition, and the soil particles are mostly fine sand and generally uniform in gradation and are non-plastic in nature. Because of this, these soils are highly pervious and generally loose in condition. From an engineering point of view, loose desert soils are often requires densification to improve their strength before construction. So desert soils are sandy, loose soil of arid regions with special engineering considerations. Finally, let us discuss the last major regional soil group in India known as marine deposit, which are formed under the influence of sea water. These soils are found in a narrow coastal belt of India. In some coastal regions, especially along the southwest coast, the sand layers are found overlay deep soft marine clays. From an engineering point of view, the marine deposits generally have very low shear strength and high compressibility, and which make them problematic for construction. And these soils also contain a large amount of organic matter which affects their behavior further. Marine clays are usually soft and highly plastic, meaning they can undergo large deformation under load. So marine deposits are weak coastal soil that require special geotechnical consideration in engineering projects. So in this video, let's stop at this point, and in our next video we will discuss various soil names that are used in geotechnical engineering, and will proceed further to phase diagram in soil water relationship. Thank you very much.